Problem 15, we have two charges, two particles with 2 microcoulomb. Let's say we have charge A, and here we have charge B, and at the midpoint between them we have charge C. The distance between A and C equals to the distance between C and B. I ask you to calculate what is the net force exerted by the two charges A and B on the charge C. So I need to calculate the total F on the charge C. You know, the total F, we have A is positive, C is positive, so FAC must be repulsive out. Here we have FAC. B is positive and C is positive, so we have a repulsive force on C by B. Here we have FBC. The net F applied, you know, FBC equals to K QA QC divided by the distance between A and C square. No, excuse me. This one F FAC, voilà. Okay, and FBC equals to K QB QC divided by the distance between R, B, and C square. You know, QA equals to QB and RAC equals to RBC. So we can say FAC equals to FBC. They are equal but in the opposite direction, so they will cancel each other. Why? Because the summation of F on C equals to FAC plus FBC. Okay, you know, FAC in the positive direction, we have plus FACI, and BC in the negative direction, we have minus FBCI. We get FAC minus FBCI, and FAC equals to FBC, so equals to O. So the net F applied on the charge C equals to O. Okay. Part B, what is the electric field at the origin due to the two charges? This one. I have to find E at the point, we have A, B, C. E as a point C. Also, you know, E as a point C equals to E created by A plus E created by B. But in general, you know, E at any point equals to or F equals to Q times E. I calculated F as the origin equals to O. As F equals to O, so E equals to O. Okay? So E equals to O as a point C, because F as a point C equals to O. Part C, what is the electric potential at the origin due to the two charges? Okay, let me explain one point. If I have one charge, charge 1, let's say positive, and here we have charge 2 negative, I want to calculate the total electric potential at the point A. So VA equals the effect of the charge Q1 here we have Q1, and here we have Q2. So we have V of Q1 plus V of Q2 equals to K times Q1 divided by the distance between this point plus K Q2 divided by the distance. Okay, you have the summation. If Q2 is negative, you put the value in the negative sign, okay? And you add. Anyway, we come back to this problem. I want to calculate the total potential at the point O. So V at the point O equals, if we have a QA and here QB, equals V created by QA plus V created by QB at the origin. Okay, so we get K QA equals to 2 times 10 minus 6. Okay, let me write before. We have K QA divided by 0.8 plus K QB divided by 0.8. You know, QA equals to QB. So we can write 2K divided by 0.8 times the charge equals to 2 times 10 minus 6 coulomb. So we get here, we calculate the value of the potential. You know, we have K equals to 8.9 times 10 power 9. I give you the value of K. You do the calculation, you get finally VO equals to 45 times 10 power 3 volt. Okay.